In this problem, we have that the half-life of Benadryl is roughly 8.5 hours. A middle-aged person takes a 10 milligram tablet in the morning. Find a model for what remains T hours after ingesting the tablet. What amount will remain after 9.4 hours? And how fast is it decaying at 9.4 hours? The first thing we should note here is our formula for exponential decay, because that's what half-life follows. And our formula is A of t equals A naught e to the kt, which means that given some time t, the amount that will remain after t hours is given by the initial amount times e to the decay rate constant times the amount of time. So we need to decide what information we were given here. To start off with, we were told that a half-life occurs 8.5 hours after ingesting the tablet, which means if we take our initial amount, which is A naught, so our initial amount is this 10 milligrams, and we multiply that by e to the k times t, which we're going to plug in our time for half-life, then we'll get A of 8.5, our time for one half-life to occur. But we know that A of 8.5 is a special scenario. That's a special case. It's when one half-life has occurred, which means half of our original amount will remain. Meaning if we take our initial amount, 10, and divide it by 2, that is the same thing as A of 8.5. So we get 10 divided by 2 equals 10e to the 8.5k, which leaves us with 5 equals 10e to the 8.5k. From here, to solve for k, that's the only value we don't know now, we'll divide each side by 10 to get the e alone, leaving us with 0.5 equals e to the 8.5k. And finally, to get rid of this e, we're going to take the natural log of each side of the equation, which gives us the natural log of 0.5 equals the natural log of e to the 8.5k. And we do that because natural log of e cancels out, leaving us with natural log of 0.5 equals 8.5k. And if we divide each side by 8.5, we'll get our k alone. So k is equal to the natural log of 0.5 all divided by 8.5, which leaves us with k is approximately negative 0.0815. We want to round this to 4 decimal places. So we now have enough information to answer the first part of our question. The model for this decay rate of this 10 milligrams of Benadryl is given by A of t equals 10e to the k times t. Remember our formula is A naught e to the kt. Well, k we just said is negative 0.0815 roughly, and t is just whatever time value we want to plug in, so it's a variable, meaning this is the model for the decay in this scenario. Now we need to find what amount will remain after 9.4 hours. Because we just made this model for how much will remain after t hours, to find how much remains after 9.4 hours, we can just plug 9.4 in for t, which gives us a of 9.4 equals 10e to the negative 0.0815 times 9.4. So a of 9.4 equals 4.6482. So we're going to go ahead and put this as a sentence answer because this is a story problem. So we'll say the amount remaining in the person's system after 9.4 hours is approximately 4.6482 milligrams. And now we can go ahead and circle that. That's another one of our answers. And now for the last part, we want to find how fast it's decaying at 9.4 hours. So the decay rate, remember whenever we deal with rates, we're talking about derivatives. So we need to find the derivative a prime of t of our model function a of t, which gives us 10e to the negative 0.0815t. Remember, when you're finding the derivative of this original function, you take this entire function and multiply it by the derivative of the exponent. So in this case, the derivative of negative 0.0815t is just the negative 0.0815. So we now have our derivative, and in order to find the rate it's decaying after 9.4 hours, we're going to plug in 9.4 into this derivative, which gives us 10e to the negative 0.0815 times 9.4 times negative 0.0815, which gives us a prime of 9.4 is equal to 0.3788. So just to go through that one more time, to find the derivative of this original function, you take the entire function and multiply it by the derivative of the exponent, which was the negative 0.0815. Okay, so now that we have this, to put this into a sentence to finish up the problem, we'll say that the amount of Benadryl remaining in the person's system after 9.4 hours is decaying at a rate of 0.3788 milligrams per hour. And we should also make a quick note here that we should mention in this top sentence up here that there is Benadryl as well. So I know this is messy, but it's not very easy to erase in this program. So we should have said the amount of Benadryl remaining in the person's system after 9.4 hours is approximately 4.6482 milligrams, just as we said the amount of Benadryl here. This way we specify exactly what we're talking about. So the amount of Benadryl remaining in the person's system after 9.4 hours is decaying at a rate of 0.3788 milligrams per hour. And this answers all three of the parts of this problem.